Now let's see the concept of bounded lattice. So it is a different type of lattice where it is actually a lattice with some extra properties. That is how we should know it. Now in a lattice we know that for every two elements there will be least upper bound and greatest lower bound, right? But then there will be certain kind of lattices which will for every element like this. It is better I'll show you a diagram. Let us say I have the relation one, two, three, four is the set and less than or equal to is the relation. So it is of course a poset, and then it is a lattice of also it is a total order. So what is total order? Every two elements can be compared here. Now in this one, if you see it, there is one element which is actually related to all the other elements, that is 2. If you look at 2 is related to every element. Sorry 1. If you look at 1 is related to 1 is related to 2, 1 is related to 3, 1 is related to 4, which means we can have 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. In some sense 1 is the least element in this, isn't it? 1 is the least element in this one, and similarly we have one element which is 4, to which every other element is related, like this 1 comma 4, right? 1 2 comma 4, 3 comma 4 and 4 comma 4, which means this is the highest bound. So this is the least bound, lowest bound, and this is the highest bound. So such an element, this element is called as upper bound and this element is called as lower bound, right? So let me take one more example and explain you, then we can again go back to the definition and look at it. Let us say we have D18. So all the divisors of 18, what are all the divisors of 18? 1 2 3 6 9 and 18, right? And if I see the D18 comma divides the lattice in the diagram, lattice diagram, so 1 is going to be here, 2 is going to be here, 3 is going to be here, similarly 6 is going to be here, 9 is going to be here, and then 18 is going to be here. Now if you look in this diagram, there is one element which is related to all the other elements, right? See this. So one element, this is related to 1 2 3 6 7 and then 18, which means somehow there is a path, and then there is one other element to which all the other elements are related. That is why this is called the lower bound and this is called the upper bound of the lattice. Earlier we were talking about the bounds by taking pair of elements. Earlier the least upper bound and greatest lower bound were the concepts where we have taken the elements, right? But here instead of taking the elements, we are talking about the entire lattice as a whole, and we are talking about the lower bound of the lattice and upper bound of the lattice, right? So these concepts, using these concepts we can define the bounded lattice. Now for a lattice, if you have the lower bound and upper bound, these two elements, then that is called as bounded lattice. Now there might be some lattices which are infinite, so in that case we might not have any bounds on them. For example, if we talk about this set of all integers, let us say set of all integers, and less than or equal to is the relation, then how can you do this? So 0 will be here, right? So I'm supposed to write it vertically. Let's say here 0 will be here, minus 1 will be here, minus 2 will be here, 1 will be here, 2 will be here, so on. There will be nothing called lower bound and upper bound. There will be no finite numbers. That is why they are unbounded. So every finite lattice is bounded. So that is one other way to define it. So now if you observe this, these are the bounded lattices, right? So just see the definition now. So why is bounded lattice important is only for the bounded lattice we have the concept of least element, lower bound and the upper bound. Now using these two we can define another concept called as complement. Therefore we are not going to look at all the lattices for complements. When we are talking about complements, we generally look at the lattices which are going to be bounded. Okay, that is why we are talking about the bounded lattice. See, now I am introducing you all the concepts. Later I'll put all these concepts together and we will solve a lot of problems. Then all the confusion will be avoided. So till then you might just feel that these topics are tricky, these topics are a bit confusing, but hold on till we come to the problems. It will be very easy. Okay, now see this. What is the bounded lattices? First, before defining bounded lattice, we are defining upper bound and lower bound. See this. Let L be a lattice with respect to R, which means R is the relation and L is the set. If there exists an element I, capital I, belong to L such that A is related to I for all A belongs to L, which means if there exists an element to which every element in L is related to, right, then such an I is called as upper bound of the lattice. So what they are trying to say is, if you can find an element like this to which all the other elements are related to, then such an element is called as upper bound of the lattice. And similarly, if there exists an element O such that O is related to A for all A belongs to L, which means if there is an element which is related to every other element in the lattice, then that is called as lower bound of the lattice. So what they actually mean is, if there is an element like this 1 and 1 is related to all the other elements of the lattice, then it is called as lower bound. So that is the upper bound and that is the lower bound. Sometimes what happens is, we might have a lower bound but we might not have a upper bound, right? For example, instead of defining this set of all integers, if I define set of all positive integers, then what happens is, we can have the element 0, right, and this is the lower bound, but there will be no upper bound. But then if both lower bound and the upper bound, if both of them exist, then such a lattice is called as bounded lattice. In a lattice, if upper bound and lower bound exist, then it is called as bounded lattice. Okay, so from this bounded lattice we can define the other lattices. So in problems I'll put all the concepts together. For now just understand these concepts, right? So what is the important point here? Every lattice is not bounded. There will be some lattices which are not bounded. They are in general lattices which are infinite, right? So what does that mean? Like this, set of all integers less than or equal to, or probably set of all integers, real numbers, and then it divides like this. So some lattices are not bounded, right? In that case what happens, we will not be able to apply some of the properties. That is why we are interested in bounded. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.